Okay, so we have two gears, and they are both one spinning at 2 radians per second in the positive direction, and one spinning at 2 radians per second in the negative direction. Now, both the gears both weigh 1 kilogram. However, this one's radius is 2 meters, and this one is 4 meters. Now, this gear is falling, and it eventually connects with this one. Now, what we're trying to figure out is the speed that the gears spin in after they connect to one each other. Okay, so we know that the initial momentum, angular momentum, is going to be equal to the final angular momentum. So let's go ahead and just deal with the first case. We know that the momentum is equal to the momentum of this first gear plus the momentum of the second gear. We also know that momentum equals the moment of inertia times the angular velocity. So let's go ahead, and we know that the L initial is going to equal the moment of inertia of the first one times the angular velocity of the first one plus the moment of inertia for the second one plus the angular velocity of the second one, which is a negative. Now, we also know that the moment of inertia for these gears is 1/2 mr squared. So we can go ahead and just plug this I into these, and we end up with the initial momentum equals 1/2 mr squared times the initial momentum of the first gear plus 1/2 m2r squared, because it's twice as big, minus or times negative the negative initial velocity of the second, and it's negative because it's going the opposite direction. Now we can go ahead and just simplify this, and we end up with 1/2 mr squared times the initial velocity minus 2 mr squared times the initial angular velocity of the second one. And we just simplify this further, and we end up with that the angular momentum equals -3/2 mr squared times the initial velocity. Now let's deal with the second, what happens after they connect. And we know, like we said, that the initial momentum will equal the final. So we know that the initial, we know that L equals I times the initial momentum, equals the moment of inertia times the angular velocity is going to equal the final. So we know that this is going to equal the moment of inertia plus the second moment of inertia. So these two are connected, so it's going to be the sum of both of those times the final velocity, which is what we're looking for. So we just go ahead and plug in the moment of inertia that we found earlier, which is 1/2 mr squared plus 2 mr squared, because the radius is twice as big, times the final angular velocity. And we just simplify this, and we end up with 5/2 times mr squared times the final velocity. Now, let's just simplify this. Actually, let's just add, we know Li that we found here, the initial momentum. So let's just go ahead and make those equal to each other. So we end up with -3/2 mr squared times the initial velocity equals 5/2 mr squared times the final velocity. And we're solving for this final velocity, so we just move this to the other side, and we end up with -3/5 of the initial velocity equals f. So we can just go ahead and we can just plug in the initial velocity that we did have, which was 2 pi radians per second. We end up with -3/5 times 2 radians per second. We end up with -1.2 radians per second. Now the magnitude is going to be, the magnitude is 1.2. However, it just depends on which velocity you do use, depending on the direction that it will eventually spin in.